Exercise 15E, crashing. This is the process of changing the times in an activity network such that the overall minimum time to complete is reduced. To reduce the overall time, activities on the critical path need to be reduced, or paths need to be reduced such that a new critical path is formed. Consider the activity network below to show the number of days it will take to build a new hospital. First of all, it's asking us what is the minimum time it takes to complete the project. So I would suggest what we need to do is to do some forward and backward scanning. So by the process of forward and backward scanning, we found that 64 hours is what is required to complete this project. A number of other reductions are possible, but each has a cost associated with the time reduction. They are shown in the table on the right, along with the cost associated with each hour of reduction. Note that each of the reductions could be completed partially, so a possible reduction of up to 4 hours would allow a reduction of 0, 1, 2, 3, or 4 hours. Reductions can only be whole numbers, for example, 3 hours, not 3.5 or 3.3. If there was an unlimited budget, what would the new minimum completion time be? So just to have a look at what each one of these is. So we've got this A, so let's go and find out what A is. Let's look at C, so there's activity C. We have activity E, which is this one. There's activity F, and then we've also got activity I. So out of these, it says here the available reduction in hours. Available means the total maximum reductions that we're allowed to do. So we are allowed to take away 4, we're allowed to, from activity A, we're allowed to take away 6 hours, 6 days from activity C, we're allowed to take away 5 days from activity E, we're allowed to take 5 days away from activity F, and we're allowed to take 15 days away from activity I. Reduced duration in hours, this would be this take away this equals this take away this is this. So the first column, take away the second column, should be equal to the third. The cost per hour in dollars, and that's how much it costs for every hour that I remove. So if there was an unlimited budget, what would the new minimum completion time be? If there's an unlimited budget, what we're going to do is we're going to totally and utterly reduce everything. I'm going to use green to indicate the new times. And what this means is that we'll need to calculate a new minimum completion time. So at this point, what I'm doing here is I'm filling in the forward scanning once again, but now I need to make sure that I get all my choices correct. So for example, just before activity G, you might remember initially I had the choice of 15 or 18, and 18 was the largest number. Here, since the earliest starting time for D is now 6 as opposed to 16, my choices are now 15, or 6 plus 2 is 8. So now I'll be choosing 15. You can see here now this is going to change the critical path. For the next one here, my next choices will be 15 plus 8, which will be 23, or 15 plus 5, which is equal to 20. So we either got a choice of 23 or 20. And so, of course, we have to go with the slowest path, So 23. At this vertex, originally it was 31. So we've got 23 plus 5, which is 28. Now this I has been reduced down to 5. So we either can do 28 plus 5, which will get me equaling to 33, or 15 plus 10, which gets me to 25. So that is going to be equal to, we'll take this largest number, so that's 33. And then 33 plus 13 is going to make that 46. So my new time, now that I've got all of these new ones factored in, is going to be equal to 46 hours. C. What is the minimum cost associated with this reduction? Include a list of which activities should be reduced and by how much. So what we need to do is, this is the hardest part of this, is that we need to now pick how many hours we should reduce from each activity in order to get that 46 hours. It is ideal here to look at, to go and do a back scanning, as well as to also look at how much needs to be reduced in order to get each of those new junctions to work. So just a reminder, the numbers in green are the new calculations to get to 46. And so let's start from the very end. So we've got finish, we've got 46, and then we get to this J, this junction here, this 33 and 25. So these were new numbers based on a reduction here. So F was reduced down all the way down to the possible maximum of 10, and I was reduced down to the total maximum of 5. So in order to keep that 33, we went via I, didn't we? Because that was 28 plus 5 is 33. What would happen if I didn't? If I didn't actually reduce that F. So F was originally 15. And so let's say I didn't do any reducing whatsoever. Well, that would mean that 25 would become 30. So it's still 33 hours is still the longest choice anyway. So we won't, don't reduce F. For I, in order to get this to work, I needs to be reduced to the maximum. So reduce I. Now, what was I initially? It was 20, so we can we can take away 15 hours. So we can go back from here again. So this was, so we got to 33, take away 5, that got me 28. 28 take away another 5, so that's going to leave me to 23. So now my choices here, I've got 23, and I initially, now which way did we get 23? We got 23 via G, didn't we? So for E, if we left E completely uncut down, left it alone, that would mean instead of 20, that would be 25. So suddenly that would be bigger. So what we need to do is we need to make sure it is equal to 23. We need to make sure that we don't get a number bigger than 23. So what we'll do is we'll make that 8. Because if we make it 8, if we cut off 2 hours, that now makes that 23. So we'll need to reduce E to 8. So that's going to be 2 hours. So E can be 2 times 40, which is equal to 80. So that's fine. And then we can go back here So then it's either 15 or 8. So therefore what we'll need to do is we need to make sure that we choose 15. So we want to make sure this was initially, so you'll notice here, so just a reminder where we got to this one here, this one that says 15, this came from the dummy. So we need to make sure that this A, C, D doesn't equal to anything more than 18. And actually we don't want to make it equal anything more than 15, I should say. So currently the choices are 8 by doing all of it cut. So what we'll do is we need to figure out how we can make that 8 that we initially cut out into 15. So let's see, we can cut out for A and C, we can do a maximum of 6 from C and a maximum of 4 from A. I reckon 4's cheaper that we can do. So let's go and see. So 4. So if we were to keep this C completely done, as in we didn't take any, if we didn't cut anything from C, kept that back at 8, what would we get? We would get, instead of 6, that would become 4 plus 8, which is what, 12? 4 plus 8? Yep, that's 12. 12 plus 2 is 14. Ooh, okay. So there we go. So 14. So instead of 8, it's now 14. So in that case, instead of reducing A or by all 4, instead of deleting 4 hours off of it, what I'm going to do is I'm actually going to just delete only 3 hours from it. So now that becomes 13. This now becomes 15. So I'm going to reduce A by 3. So that's going to be 3 by $80. So we don't want to reduce C at all. And the answer is $1,070, which, whew, that is correct. I have checked these answers before. So where might you see a question like this? This is a very typical SAC question. And also you might find that this would be sort of like the last question in the exam 2 section of networks.